Hey guys, here is our very first video for the week. This one is over one-step inequalities. Inequalities are very similar to equations, especially with how we solve them, but they're a little bit different. They involve symbols, so let's talk about symbols first. This symbol right here is your greater than symbol. It's important to know the symbols and what they mean, or which symbol is which, because unlike when you were in elementary school and you could just do the little alligator eats the biggest number, you don't always have two numbers. Sometimes you have a variable and a number, and so you need to be able to recognize right off which symbol is which. If I take this symbol and put a line underneath it, then what it means is I have a number that is greater than or equal to, which means it can be greater than the number or it can be equal to the number, and you'll see what I mean as we get to some of these problems. A symbol facing this direction is your less than symbol. And of course, if I put the line underneath it, like with greater than, then this means less than or equal to. So it includes them both. That is an ugly N. There we go. So those are your symbols. I want you to be familiar with them, so have these written down somewhere so you can refer to them, because I'm just, I need you to be able to recognize them when you see them. So let's talk a little bit about inequalities really quick. Let's erase what I have written here because it doesn't mean anything to you at the moment. Let's try that again. Think about this statement. How many answers satisfy the following inequality? X is greater than 4. And so start thinking about values of X that would make this true. Well, the first one that comes to mind is 5. 10 is also greater than 4. 5.1 is greater than 4. 5.01 would be greater than 4. We could even go really obvious and say 118, 108 would be greater than 4. We could go on all day listing numbers that are greater than 4. And so, I could sit here for hours and we could have a little competition to see who could list the biggest one, which would not get us very far because I could always just add 1 to whatever you said. But here is the point. Now that I am rambling, inequalities don't just have one solution. Like when you solve an equation, you get an answer x equals 4. That means x is 4 and can't be anything but 4. When you get an answer to an inequality, you have an infinite number of solutions because there is an infinite number of numbers that will satisfy that statement and make it true. So inequalities have lots of solutions, and because of that, when we write the answer to an inequality, we don't just write x is greater than 4, we also have to show it in a graph form so that we can show all of the numbers that would be solutions. And then there's also this thing called interval notation, which we are going to talk about. Interval notation is going to be very important to you because when we start talking about stuff called domain and range, interval notation comes back up. So you're going to see it today and throughout the rest of this unit, but you're going to see it again. So it's one of those things that's going to stick around. I don't know why the number 1 shows up twice here, but it's okay. Our first one is m is greater than or equal to 3/4. That means that m is any number greater than or equal to 3/4. So in order to graph an inequality, you always draw a number line, and I always shortcut mine, okay? Here is 0. 3/4 is going to be to the right of 0. So this would be 1, this would be 2, this would be 3. We could continue on, and then over here would be your negatives. And in between 0 and 1 is going to be your 3/4. And we want to graph, I'm going to change colors, but we want to graph all of the numbers that are greater than or equal to 3/4. If a number is greater than 3/4, that means it is going to be to the right of 3/4. So after I finish with this problem, I'm going to end up drawing an arrow that goes to the right. It's this equal to part we have to talk about. M can be 3/4 because of the or equal to, but it can also be greater. So when I first represent this on my graph, I'm going to put a circle at 3/4. Oh, we need a brighter color than that. We're going to put a circle at 3/4 and we're going to color it in because 3/4 can be considered part of the solution. But since it's not just equal to 3/4, it's also greater than, we draw an arrow that goes to the right, and hopefully you can draw a straighter arrow than I just did. But this is the graph of that solution. It starts at 3/4 and includes it, and then goes to the right to show that all numbers bigger than 3/4 count. So interval notation for this would start with 3/4 and go to positive infinity because it doesn't end. It goes all the way to positive infinity. Now, since 3/4 is included in our answer because of this or equal to part, I put a bracket right here. That tells the person looking at your answer that 3/4 is included. And then you put a parenthesis around infinity because infinity is not really a number. It is a symbol that represents that something continues on forever. So I cannot include it in my answer. So it has a parenthesis, and it always has a parenthesis because it cannot be included. So let's do another example. So I have 10 is greater than t. Here's my issue with this problem, okay? In order to be able to graph properly and to write it in interval notation, you really need your variable to be on the left. In this problem right here, the variable is not on the left, it's on the right. So I'm going to rewrite. I always will do this because I like my variable on the left. It's just easier for me to understand. In order to rewrite this, I'm going to put the t on the left, but then everything else flips around, including the symbol. So the symbol flips and the 10 goes to the other side. These mean the same thing. 10 is greater than t, or t is less than 10, is what that means. They mean the same thing. They're both correct, but I like my variable on the left. So we're going to graph this. I have 0, 2, 4, 6, 8, 10. I'm going to skip numbers this time so I can get everything on there. And then these would be your negatives, -2, -4. And then if I wanted to graph, I'm going to change colors again just so you can see. I need t to be less than 10. Now this just says less than. It does not say less than or equal to, which means 10 cannot be included in my answer because t does not equal 10. It's just less than 10. That means when I put a circle at 10, I leave the circle open to show that I'm starting at 10, but 10 is not included. So it's not colored in. And then my arrow this time gets drawn to the left because I'm doing numbers less than 10. Okay? Now, interval notation, we always go from left to right, the smallest number to the biggest number. The smallest number that this is going to approach is going to be negative infinity because it goes to the left forever and ever. And like I told you before, infinity always has a parentheses in interval notation, and it goes all the way to 10. That's where we stop. Now 10 is not colored in because it did not have the line underneath the symbol, so 10 also gets a parentheses to show that it is not included as part of the answer. So I go from negative infinity to 10, but 10 is not part of the solution. So let's do a couple more. Here what you have, I need this out of the way. Here you are given the graph and you are asked to write the inequality in the interval notation. So here is a graph. I see that my arrow points to the left, which means that whatever I have has got to be less than, and I'm going to just use the variable x. And it's got to be less than 2, and 2 is not included because this circle is not colored in, so it just is the same thing as x is less than 2. So interval notation would go, since it goes to the left, negative infinity to positive 2, and since neither one is included, it's just they're both in parentheses for the interval notation. Now for the next problem, you see it's going to the right, which means I'm going to have a greater than symbol, and my circle here is colored in, so it makes that or equal to. So I have greater than or equal to, and the circle is at negative 0.5. This tells me that negative 0.5 is part of my solution. Because it's greater, it goes all the way to infinity. So I go from negative 0.5, which is included, so I have a bracket, to positive infinity. So there's how we go from the graph to the inequality, and then we practiced graphing just a second ago. Now let's solve. Quick and easy. It's just like an equation, okay? Nothing really has changed. 4x is less than or equal to 20. If I were going to solve this like an equation, I would just divide both sides by 4. Well, that's exactly how you solve this. You keep the symbol, though, so it's less than or equal to, and 20 divided by 4 is 5. So the value of x in this inequality is everything less than or equal to 5. So here's how I shortcut my graphs. So I get tired of drawing all the numbers. I put my positive 5 and my negative 5. And because this is less than or equal to at 5, I'm going to color in my circle. And since it is less than, my arrow has to point to the left. Now, we're not going to write this one in interval notation. We're just going to graph it. That's going to be the important part of your answers. You can't stop here. You also have to draw the graph. So the next one, I have 2/5 plus y is greater than negative 6/5. I have got to solve this for y. There is a plus sign here, so I'm not. It means I have to do the opposite of this 2/5, which is negative 2/5. And they were really nice to you and gave you two fractions that had common denominators. So you have y is greater than negative 6 minus 2 becomes negative 8/5, which is the same thing as negative 1 3/5. It's the same thing. So however you want to write it, it doesn't matter to me. But when you graph it, you have 0 here. We're going to have negative 1 here and negative 8/5 here in between it and 2, negative 2. And then here we have positive 1, positive 2. Now, if I'm going to graph this, I have y is greater than that number. So it is not greater than or equal to, which means when I graph it, I do not color in my circle. And I draw my arrow to the right because it's everything greater than. So let's talk about when these are special. The only time inequalities are different from equations is whenever you are multiplying or dividing by a negative number. Here is the rule when that happens. When multiplying, I'm going to abbreviate, or dividing by a negative number. What I mean by a negative number is if you do 4 divided by negative 2, not if you do negative 2 divided by 4. It has to be the number you're dividing or multiplying by. So when you're multiplying or dividing by a negative number, you must, it is not an option, switch the sign. And I'll show you what I mean. We're going to do an example, a couple of them actually. And you'll get really used to this because this, I mean, it's just not, it has to happen. If you don't switch the sign, your answer doesn't make sense. So this inequality right here, I have negative 5x is greater than or equal to 15. If I want to solve this inequality, I have to divide by negative 5 on both sides. In this case, the number I'm dividing by is a negative. So when I solve my problem, this symbol right here has to flip around. And so it's no longer greater than, now it's less than. And 15 divided by negative 5 is negative 3. And so if you were going to graph this on a number line, at negative 3, you would color in your circle. And because you flipped your symbol, you're going to use the less than when your arrow would point to the left. That would be what your graph looked like. So now, another example. This one right here, negative 4 is less than t divided by 3. T right now is on the right, and I told you already I don't like that, so I'm going to rewrite this as t divided by 3 is less than negative 4. I just turn everything around. To solve this, I have to multiply both sides by a positive 3. I know that there is a negative in the problem, but the number I am multiplying by is a positive, and because of that, it does not switch my symbol when I do the multiplication. Because this number is positive, the one I am multiplying by, the sign does not have to flip. So this just becomes t is less than negative 12. And if you were going to graph it, I'd have negative 12. And at negative 12, I would have an open circle because it's just less than, and my arrow would have to point to the left. So let's do a couple of word problems really quick just to make sure we get the point. So the first one, I actually want to skip down here to the triangle one because I really want to make sure I get this one in. You're asked to determine the value of y so the perimeter of this triangle is less than 100 meters. Perimeter means add all the sides. 3 plus 5 is 8 plus 12 is 20y has to be less than 100. And you would solve that by dividing both sides by 20. I don't have any negatives, so it just says y is less than 5. And that's the answer. So that is solving inequalities one step. Do not forget the rule about multiplying and dividing with a negative number. Make sure you remember that. And try this one. The 10 is at least a number divided by negative 2 on your own. We will check it tomorrow. Have a very good rest of your evening.